Summation and integral calculus. Okay, so we are continuing the summation and integral calculus. Summation and integral calculus. We have already talked 2 points in which the kind of it matters. What matters? There are two ways to bring a mathematical computation into integral calculus. One location is where someone is seeing multiplication of two items. Function over x multiplied by x. Function over x multiplied by x. 2 into 3. Neither 2 is function over x. 3 I can represent as x. 2 into x. 2 is not a function over x. It is constant. 2 into x. Function over theta into x. Function over theta into x. These are candidate to not bring into integral calculus because the left side or one operand of the operator multiplication is not function over second operand. But if it is fx into x, like sin x into x square into x, if this kind of multiplication comes into picture, then this can be solved only by integration, not by the multiplication. Sin x into x is not x sin x. Sin x into x is cos x. This is called integral calculus. If someone is seeing multiplication, I have seen in the book. Now let's integrate over this reason. Let integrate. These are the why. That's why people they left mathematics. Integration is nothing but multiplication. That's it. Multiplication higher term name is integral calculus. Rather than they would have named it multiplication calculus and division calculus. That was better word. So integration is nothing but simple multiplication. How multiplication is achieved? One way of achieving multiplication is calculation of the area. If I say 2 into x, someone can draw a rectangle where one side is x, another side is 2. It forms a rectangle. Try to find area of rectangle through any mean, not through multiplication. People will say, I know. What is the area of a rectangle? 2 is the height, right? Base is x, 2 into x. Without multiplication, can we get area of a rectangle? If someone can get, then that is 2 into x. Means a multiplication can be solved by drawing a graph. If that is true, then sin x into x, where height is sin x, which is variable with different point in x, can also be computed through the graphical way, and that is the accurate way. Okay, there is another point where the mathematical computation converges into integration, and that is summation. If you have lot of summation of items and they are coming to each other, full summation can be brought into integral calculus. Okay, multiplication can be brought in integral calculus and summation can be brought in integral calculus. Two area where integral calculus helps a lot. What is summation? If I have a problem, what is problem? If I have a problem, consider I have I have uh, I have alpha dollar. I have alpha dollar in my pocket, or I have alpha ruble in my pocket, or I have alpha yuan in my pocket, or I have alpha rupees in the pocket. Okay, consider I have alpha rupees in the pocket. Okay, now I have a bunch of coins. Makes sense? I have a bunch of coins. If I have a bunch of coins, I throw it. Now I count number of heads. If number of heads are 10, okay, I have bunch of coin of n coins. I I count number of head. Number of head are 10 and number of tail are n minus 10. Now the my money will become double. The number of heads are, if number of heads are 10, I have to double my money 10 times. Alpha will become 2 alpha if there is one head. If there is another head, then 2 alpha would become 4 alpha. If there is another head, then 4 alpha would become a 8 alpha. Someone can think in this fashion. Okay, if I see tail, then I have to make it half. So if there are 10 number of heads are there, 10 2 to the power 10, I believe it will come like that. I have to multiply by 2 to the power 10. If there are if there are 10, if there are n minus 10 heads tail are there, then I have to multiply by 1 by 2 to the power n minus 10. Now tell me how much money I have. So there is a question that if I have n number of coin, I have n number of coin, and I throw it. Okay, what is how much I can expect my new rupee now? I right now I'm carrying a rupee note and that carry worth alpha rupee. I have a alpha rupee note. Okay, rupee can be Nepal. I have Nepali rupee. I can show. Okay, there are okay. Rupee is not a very simple thing. In earlier days, I believe till 50 years back, the Indian rupee was in circulation around Indian subcontinent. Even United Arab Emirates, they were using Indian rupee only. Okay, Indian rupee was devaluated, and then Indian government they released another Indian rupee called Gulf rupee, and that was used in United Arab Emirates. They devaluated again, and they become a kind of came in compulsion to release their own currency. Otherwise, Indian rupee was in circulation in United Arab Emirates, Dubai, and those places. And then Indian rupee was anyway it was in circulation in Afghanistan, Pakistan, Nepal, Bhutan, Burma, Sikkim, Sri Lanka, all where Indian rupee was working. But the way Indian rupee was devaluated, then later the Indian rupee, all countries they started publishing their own rupee or they changed their currency. So this is the I believe old note. This is in UAE rupee or UAE dirham. This is UAE dirham. Okay, this is Nepali rupee. This is 10 rupee from Nepal. Okay, this is 10 rupee from the Nepal. This is 10 rupee or 10 dirham from the UAE. Anyway, now consider 10 dirham. So I have alpha dirham, or I have alpha Nepali rupee. I have alpha Nepali rupee, and I have n number of coin. I just throw it. If it is head, if I see a coin, it is head, my rupee become double. If there are 10 heads, then it will become 2 to the power 10. If there are n minus 10 tails, then it will be 1 by 2 to the power n minus 10. Now the question is, if I have alpha rupee, I have 10 rupee. The question is, I have 10 rupee Nepali rupee in my hand. Earlier all were Indian rupee only, but now there is a Nepali rupee separately. Okay, the way the political sentiment these people in Indian government, the political sentiment, the way they blown whatever it is, they circulated in the country, that these country forced to circulate their own rupee. Otherwise, it was Indian rupee everywhere. Anyway, now if there is a 10 Nepali rupee is there, 10 Nepali rupee is there, and then a person has n number of coin. Now he is throwing the coin. Now, what is expectation of the new rupee? What is the average expectation of the new rupee? Average expectation that there is a chance that that there will be one head and n minus one tail will be there. There is a chance. If I throw the n number of coin, then there is a chance that number of head will be zero and all tails will be there. Then 1 by 2 to the power n, that much times the rupee value will go down, because rupee will, I have to, this much I have to get, I'll get a new rupee. If there is one tail, then 10 by 2, I'll get 5 rupee. If If again one tail comes, then 2.5 rupee. Again one tail comes, then 1.25 rupee. It will go by half, 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 half. If I see one head and I had 1.25 rupee in my hand, immediately I'll get 2.5 rupee. Again one more head, 5 rupee. Again one more head, 10 rupee. Again one more head, 20 rupee. Again one more head, 40 rupees. Like that. What is the average expectation after n number of coin if I throw on average? Okay, not that guaranteed average. If I n number of time n number of coin if I throw on an average, how much money I can expect in my hand. At the beginning, I have 10 rupee in my hand. Okay, if I have 10 rupee in my hand, how much I would expect? So this we will solve later. Okay, these are the way where consider where n tends to infinity or whatsoever. These are the way that falls in summation. Typically summation. Okay, where we sum the thing and then we think that if it can be brought into integral calculus to make the calculation more intricate and more clear and more accurate. Okay, so we are pursuing discussion in calculation of the area of a circle. We are pursuing the discussion in the calculation of area of a circle. What is area of a circle? Okay, in that fashion, we are talking about two coordinate systems. One coordinate system is called theta and r coordinate system. This is theta and r coordinate system, other gone. Okay, this is theta and r coordinate system. Okay, this side. Now, consider that I have another coordinate system. Consider this is x and y coordinate system. I had one more. Okay. Oh, okay. Now consider this is theta r coordinate system, and I have another coordinate system called x and y coordinate system. This is theta r coordinate system. This is theta r coordinate system. This is xy coordinate system. In theta r coordinate system, I have a rectangle. In theta r coordinate system, I have a rectangle. Rectangle means if I say this is theta r coordinate system and in theta r coordinate system I have a rectangle. If someone watches the rectangle considering theta as independent variable, theta is changing. If theta is changing in the rectangle, the height that is radius is not changing. Radius is fixed, theta is changing. If theta is changing and radius is fixed, it will make a rectangle. Okay, I have another coordinate system called x and y. This is x-axis, this is y-axis. Now I have a coordinate system x and y, and there I draw a circle. Okay, don't draw a circle. Who is asking you to draw a circle? This is x and this is y. This is independent component, this is dependent component. No. Okay, yes and no. If it is only Cartesian coordinate system, then yes, x is independent component and y is dependent component. Okay, there is another coordinate system called theta and r coordinate system. In theta and r coordinate system, it's r and theta. In theta and r coordinate system, I have a rectangle here. How this rectangle is an area. How this rectangle would be mapped into xy plane. What is relationship? Tell me. X equal to function over r and theta. Y equal to function over r and theta. X equal to r cos theta. Y equal to r sin theta. And in theta r plane there is a rectangle. If there is a rectangle, r is not variable with theta, even though theta is changing. If x equal to r cos theta, y equal to r sin theta, x square plus y square equal to r square. Means looks like if I mix these two coordinate systems, this is x-axis, this is y-axis. If I try to draw r and theta coordinate system here only, then r square equal to x square plus y square. It is giving a hint that there is a circle, because x square plus y square equal to r square is a circle of radius r. Means there is a circle here of radius r where r is constant. Certainly in circle radius is constant, centered at the 0. Okay, theta I have made in theta r plane variable where r is not changing. Okay, if that is the case, then what is r? R is x square plus y square square root. If this is x axis, this is y axis, r is the radius of the circle. If I am moving this radius like this, radius is not changing, radius is constant. And looks like if I move, if I move this radius where radius is not changing, what is changing? Angle is changing. Looks like the similar to rectangle in theta r plane, there is a mapping of rectangle in the xy plane is a circle where x equal to r cos theta and y equal to r sin theta. R is not variable, theta is variable. It forms a circle. We are trying to find area of a circle. Okay, in that fashion, we will take the ith section. What is ith section? Now I divide this circle into n part. This is the radius. This is the x-axis. This is y-axis. Now, if this is x-axis and this is y-axis, then I make this radius go like this. One snapshot, then another snapshot, another snapshot, another snapshot. I am dividing this circle into n different parts. Many times I have intimated this. Okay, this proves if this is x-axis, this is radius. This is the first section into the circle, second section into the circle, ith section into the circle. Then we will make sections and it will make n sections. If I talk about the ith section, if I know the area of this ith section, or if I know area of all the section, and if I add it all the area, it becomes area of the circle. That is summation of I equal to 1 to n area of the ith section. Then it gives the full area. What is the area of the ith section? That is the first point. Okay, area of the ith section, whatever is found in the book, generally find in the book, that is not understandable. There it is that if this is radius, then this is also radius. Both are same. If this is the arc of the circle passing here, then if this angle that is delta theta I of the ith section is very small, this arc can be considered as a straight line which will fall at 90 degree on this radius. Length of this arc into length of this arc divided by 2 will be the area of this triangle. Okay, means length of this arc into this arc will give area of a rectangle divided by 2 will give area of the triangle, that is 1 by 2 r square delta theta I. Summation I equal to 1 to n 1 by 2 r square delta theta I. If I sum for all the I get the area. So this is not satisfiable because we are making arc as a imagination that it is a straight line. What about r is a function of theta? At this point radius is this. When radius moved like this, radius became smaller because radius changes when angle changing. Now what is the area of this triangle? If I say 1 by 2 r square, 1 by 2 r square delta theta I, then this is the r, if this is r1 and this is r2, then r1 into delta theta I is this r. Okay, 1 by 2 into r1 into r2, 1 by 2 into r2 into r1 delta theta I, this certainly it will not give the area of this, but people go with it and say that area of the ith section where radius is constant or radius is function over theta, whatever it is 1 by 2 r square delta theta I. And this summation, if n tends to infinity, then it can be brought up into integral calculus as 1 by 2 integration of theta 0 to 2 pi or whatever it is. R square will become function over theta whole square if it is function over theta. If not, then r square, which is a constant, it will come out d theta. Please watch our previous videos that how to bring the summation into integral calculus. This works. Okay, this works. Okay, this works. What is our methodology is? Our methodology is that that to find area of something, you do cross product of two vectors. That's it. You do cross product of two vectors and you get area of something. Okay, if now I'm trying to find area of the ith section. Okay, this is one vector and arc is another vector. Either arc is like this or arc is like this, whatever. If I have arc vector and this vector or this vector, if I have a arc vector and this vector, or arc vector and this vector, if I do cross product of these two vectors, if I do the cross product of these two vectors, then I get the area between these two vectors. Makes sense? If this is a vector and this is a vector, if I do cross product of these two vectors, I get area in between, that is a parallelogram. Okay, but this vector, which is a straight line, can be replaced by a curved line also. No problem. Okay, if this is a curve and this is a line, this this is a vector. This is a vector and this is a curved line. If I do cross product of this curved line and this vector, it will give the area in between. Are you sure about it? Anyone would ask, are you sure about it? Okay, first of all, how you will describe a vector of a curved line, that is my responsibility. If this is a curve and this is a vector, if I do cross product of this vector and this vector, it will give area underneath. This is a big thing we are talking now. What is challenging here to represent a curved line through a vector? Please watch our previous video or a video series called length vector. Okay, length vector is a vector which represent a curved line also. How to get length vector is, if you take a straight line, then how to represent a straight line into a vector? If this is a straight line and this is x-axis and this is y-axis, this is origin 0, 0 and this is a point called x, y. If I want to represent this line as a vector, what is this line? Consider this line is y equal to kx, where k is the slope, y equal to kx. In that fashion, this point can be 1, k, or this point is x, y. What is the vector representation of a line that is y equal to kx? Or people would have read in the book y equal to mx. Okay, in that fashion, if I want vector representation, consider this point on the y equal to kx. This point is x, y, and this point is 0, 0. If it is x, y, then y will be k into x. It is actually x, kx, whatever it is. This vector will be xi plus yj. Vector representation of a straight line passing through origin and point x, y will be xi plus yj. Make sense? This is a length vector. Length vector means if I calculate the magnitude of this vector, it will give the length of this vector. Okay, x square plus y square square root. What is the vector? Length vector will go along the line. What is the vector representation of a curved line? If I say vector representation of a curved line, then curved line, if this is a straight line, okay, curved line. Curved line is connecting a point 0, 0 and end point x, y. If I represent this as xi plus yj, it will be representation of a straight line, not the curve. The curve vector is like this, all along the line curve vector. There is a set of vectors. They make together to say it is a curved line. If there are a set of vectors, then it will be algebraic vector, whatever it is. In a simplest manner, if I say curved line, therefore curve, if this is x-axis, curved line everywhere y by x, y by x, y by x are different. Whereas for a straight line, y by x, y by x, y by x will be same. So whatever the vector representation we are making to represent curved line, I have to place y by x, because y by x is variable in curved line. Anything I represent, I have to make sure that variable part will be there. So xi plus yj I can rewrite as I plus y by xj bracket close into x. This is the represent where y by x is available. This is a representation of a curved line. So curved line vector, if it is division, and numerator is dependent upon denominator, I can convert into differentiation. And I plus y by xj, where y is a function over x, this is full-fledged function over x, into x will become integration. So curve vector is I plus dy by dxj, bracket close, into dx. Okay, if I'm trying to find, then this is the algorithm how to find a curve line vector. First represent a vector in its normal form, and then take out the independent component, and then convert the division into differentiation and multiplication into integration. It becomes a curve line vector. This is the algorithm. If I'm trying to find area of the ith section of the circle, this is the ith section of the circle. Okay, this is delta theta I. This is theta, it is making with the x-axis. This is the arc of the circle. What is area of this ith section? Area of this ith section to compute, let's do cross product of this vector and this curve vector. What is curve vector? If I see polar, first of all, I'll take polar coordinate system, not the xy coordinate system. Why we will not take xy coordinate system? Means this vector in xy form, this vector in xy form, and cross product. The reason is that if let's proceed. Let's take polar coordinate system. Polar coordinate, what is representation of this curve vector? In polar coordinate system, if I am representing polar coordinate system in Cartesian coordinate system, this is x-axis, this is y-axis. In this Cartesian coordinate system, if I draw polar coordinate system, then there will be radius and it will be angle. Whereas in actual polar coordinate system, theta is like this and radius is like this. They are again a perpendicular to each other. But if I mix polar coordinate system, draw polar coordinate system inside the Cartesian coordinate system, then it will be radius will be like this and it will make angle theta with the x-axis. Radius will keep growing. This is a hybrid model. Okay, in that point, if there is a circle like this, if there is a circle like this and this is x-axis, then any point P, if I talk, then in polar coordinate system, the point P will be r comma r theta. R theta means if I move theta degree like this, then it will travel r theta of the distance. So this point will be this distance, comma this radial distance, r comma r theta, not r comma theta. R comma theta is a point in polar coordinate system in polar coordinate system. If I have a polar coordinate system like this is theta and this is r, then any point is r comma theta. But if I am in Cartesian coordinate system, this is x-axis and this is y-axis, this is radius and this is angle. If I take any point x comma y, then in polar coordinate system it will be r comma r theta distance. Okay, in that fashion the p vector is r unit vector plus r theta unit vector. Now what is the okay, what is the angle of, what is the area of the ith component? If this is ith component, I divided the circle into n number of parts. We have demonstrated it at the beginning one. What is the area of the ith component? Area of the ith component is this vector cross product with this vector. This vector if I take, then radius is moving and theta is constant. If I take this vector, then theta is moving. Radius may be constant, radius may not be constant, whatever it is. Now we have, what is the area? This position vector or length vector cross product with another position vector or length vector. Length vector, this cross product with the length vector of this. What is length vector of this? Okay, what is the length vector of this? That is r unit vector plus r theta unit vector. I have to take out independent component here, and that is r. It will become d, then it will become r by r unit vector plus r theta by r, where r is constant, theta unit vector. Cross product, there I have to take out theta, then it will become r by theta, r unit vector plus r theta by theta unit vector. Outside theta will come. If I change division into differentiation and multiplication into integral calculus, it will become dr by dr, r unit vector plus r d theta by dr, theta unit vector. Cross product, dr by d theta, r unit vector plus r d theta by d theta, theta unit vector, bracket close. Outside it will be dr d theta. This is the area. This is the area. Okay. Now let's watch. Let's keep the dr and d theta outside only. Now it is cross product of two vectors. One is dr by dr r unit vector plus r d theta by dr theta unit vector. This is exactly same as dp by dr, d position by dr. Cross product dp by d theta means the area, means what we are trying to say is dp by dr cross dp by d theta into d theta dr. Leave that part again. Now cross product of these two vectors, what it says, if I combine it, then it will become dp p. P is a position vector of a point, mind it. P is a position vector of a point, that is a length vector. Again, P is a position vector of a point, that is length vector. dp by dr cross dp by d theta. If I combine this cross product, then it will become dp by dp by dr d theta, where the P will become a point as an area point. There is one line point and one is area point. Position vector can represent a area point. Position vector can represent a line point. If I have a surface and this point is x comma y, this point is lying on the surface. If I draw a position vector, it is xi plus yj. This is a position vector of a point lying on an area. If I say dp by dr cross dp by d theta, these 2 points are the point on a line. If I combine this, it becomes dp by d theta dr or dp by d theta r. Then top point will be point on an area. The concept is, if I move 1 unit of area, if there is 1 unit of area change, dp by d theta r, if there is 1 unit of area change in theta and r plane, then how many unit of area change I see in P? That is dp by d theta r. If I know that per unit area change in theta r brings how many unit of area change in P, that is in the Cartesian coordinate system plane, per unit change. With that, if I multiply with delta theta I delta ri, delta ri is the change in radius in the ith section of the division. This is r1, this is r2. Delta ri is r1 minus r2. Delta theta is this theta with the x-axis and this theta with the x-axis. If I subtract, this is delta theta I. If I know per unit area change brings how many area change in P, then if I multiply by delta Ri and delta theta I, then I get this ith section area. Means now the area of the circle is summation of I equal to 1 to n dp by d theta cross dp by dr cross dp by d theta. Magnitude I would say, because this will lead into a vector itself. Magnitude. Then delta theta I delta theta r. Makes sense? Delta theta of the ith section, delta r of the ith section. Summation I equal to 1 to n. And in magnitude or modulus, delta p by delta r cross delta p by delta theta. Magnitude. Delta theta ith section, delta r ith section. This summation will give the area of the full circle, where the inside is the area of the ith section. Now question is, can I proceed same way through length vector? Same way through length vector. If I substitute this in length vector the way we did, then length vector if I see, then this will be, consider this point in x comma y. Then this I have to describe as a length vector in x and y. This I have to describe length vector as x and y. We are in Cartesian coordinate system. This is x-axis, this is y-axis. Now in that fashion, this line will be xi plus yj. This line will be again xi plus yj. If I say this line I have y as variable and this line as x as variable, then one vector will become I plus dy by dx, j bracket close dx, cross product dx by dy, I plus j bracket close dy, the way we did in the polar coordinate system. Altogether it will become like dp by dx cross dp by dy. P is xi plus yj. dp by dx means I plus dy by dxj. dp by dx cross dp by dy. Magnitude delta xi delta yj. Delta x means if this is the area, then delta x is the this much x change, and delta y means ith section of the area we are taking of the red. I divided this circle into n number of parts. This is the ith section. Delta x is this much. From here, x axis here, x axis, this is delta x. This is delta y. Means the ith section area is dp by dx cross dp by dy. Earlier it was dp by dr cross dp by d theta. Now dp by dx cross dp by dy magnitude delta xi delta yj. Will it give the area of the ith section? Certainly not. This is what we are talking. Certainly not. Why it is not? Because if I talk about the position vector p, that is xi plus yj, y is dependent upon x in Cartesian coordinate system. If y is dependent upon x, dp by dx, we are trying to see how much p is changing if there is change in x, where p is x and y, where y is function over x only. More or less, how much x is changing when there is change in x. dp by dy, okay, dp by dy, that is also will come in x only. How much x is changing when there is change in x? What it makes sense? How much x will change if there is 1 unit of change in x? This is vague state. dp by dx cross dp by dy will not work if we take Cartesian coordinate system. It will work if dp by dr cross dp by d theta. If we are taking in Cartesian coordinate system, r and theta, if I take in Cartesian coordinate system, then then r and theta are independent variable, and x and y are dependent variable. Things change drastically. X equal to function over theta and r, y is function over theta and r. In that fashion, x is r cos theta, y is r sin theta. If I talk about the Cartesian coordinate system, then I have a radius like this which is moving like this. Okay, but actually, so I say this is radius and this is angle, but this is polar coordinate system. This is not polar coordinate system. Polar coordinate system we are trying to draw in the Cartesian coordinate system. In that fashion, polar coordinate system, that is r and theta are independent components, and x and y are dependent components. That's why dp by dr cross dp by d theta work. If I try to calculate area, then two sides of the area, that is one side is radius and one side is theta, must be independent of each other. If I trying to do same thing with the x and y in xy plane, then y is dependent upon x. If I talk about the area, x and y should be independent to each other. This is called miniature science. This will not work at all. Anyone can try. This will not work. This will work only in r and theta, because we are trying to draw r and theta in xy plane where r and theta are independent and xy are dependent. In that fashion, if I have taken an area where two sides are independent to each other, one is r and one is theta, it will work. If I had taken the in theta r plane, dp by d theta cross dp by dr, it would not have worked, because there r is a component dependent upon theta, but I took in xy coordinate where r and theta are independent, x and y are dependent upon theta and r. Okay, how to compute area of a circle in when I want to do cross product of two vectors? That is not possible in x and y in xy coordinate system. Then I have to try in theta. Let's try other way. Anyone would say try other way. If this is theta or this is xy plane and this is theta r plane, the way we did theta r plane merge into xy plane, making xy dependent upon theta and r, merge the x and y into theta r plane. Makes sense? We will try. I have never done it. It's not there in the book at all. Anyone can. Merge the xy plane into theta r plane, and then go for the dp by dx cross dp by dy magnitude dx dy, or delta xi delta yi, summation I equal to 1 to n for the ith section. Try. Okay, if I try so, then I have to find similar way. If someone trying to draw a diagram, then x equal to r cos theta, means in theta r plane x equal, if r is constant, then r cos theta will be a cosine wave. It will be a cosine wave in theta r plane. y equal to r sine theta, it will be a sinusoidal wave. It will start from origin and it will go like this. Cosine wave will be start from the r cos theta at r height. R cos theta at 90 degree, it will be 0 and it will go like this. R sine theta will start from origin, that is 0, and it will go like this. These are the two waves of x and y in the r theta plane from the xy plane. If this is xy plane and this is r theta plane, in xy plane, if I try to draw r theta where x equal to r cos theta, y equal to r sine theta, then it will go like a circle. But if there is a circle and if I go in r theta plane where x equal to, I'm sorry, where r equal to a square root of x square plus y square. Other way, here x equal to r cos theta, y equal to r sine theta. X and y are dependent upon r and theta. In theta r plane, in reverse fashion, r and theta are dependent upon x and y. X and y are independent here. Then I can go dp by dx cross dp by dy. Delta xi delta yi. Summation I equal to 1 to n. What is dp? P is position vector along whatever I draw here. Position vector is r unit vector plus theta unit vector, not r theta unit vector, because this is r theta plane. In r theta plane, any point will be r comma theta. It will be r comma r theta, the way we did there. In that fashion, dp by, if I say, now it should work because now x and y are independent and r and theta are dependent. dp by dx cross dp by dy. What is p? P is r unit vector plus theta unit vector. What is r? R is a square root of x square plus y square. A square root of x square plus y square. D of what is position vector? Position vector is a square root of x square plus y square r unit vector plus tan inverse y by x. Tan theta equal to y by x. X equal to r cos theta, y equal to r sin theta. Then tan theta equal to y by x. Theta equal to tan inverse y by x. Position vector here in theta r plane will be that square root of x square plus y square r unit vector plus tan inverse, that is theta, tan inverse y by x theta unit vector. dp by dx, d of square root of x square plus y square r unit vector plus tan inverse y by x theta unit vector. D of that by dx, keeping y as constant, cross product dp by dy. Okay, keeping the x constant, calculate the cross product of these two. And then delta xi, delta yi. Now I can, if someone sees this, then it will become summation I equal to 1 to n. And then dp by dx cross dp by dy. This is the ith area magnitude, ith area, dp by dx cross dp by dy. Delta xi, delta yj, delta yi. Okay, this whatever comes, this will come as a, consider x and y is a axis. This axis is called x into y axis, xy axis. This is function over xy axis. This xy axis, this is function over xy axis. If I draw a graph where the height is fxy and this is xy, okay, if I chop this xy into n different parts, if I take one part, then this length is ith part, then this length is delta xy. Delta xy into fxy will give the area of this strip. If I add all the area of this strip, then it will become area of this line underneath it, line underneath the area. If I get the area of a delta section and add all the area, it will become full-fledged area, that is fxy dxy. So it will turn as integration of xy from the begin to end. Okay, and then fxy dxy will become dx dy, and fxy is what we have now. Someone can calculate, I have not tried it. D of square root of x square plus y square r unit vector plus tan inverse y by x theta unit vector. D of that by dx, cross product d of square root of x square plus y square r unit vector plus d of, in bracket, square root of x square plus y square r unit vector plus tan inverse y by x theta unit vector by dy. Here x is constant, here y is constant. Calculate it, do the cross product. Cross product will come as a r and theta. If someone does the cross product, then it will come as a anything else. It can be z vector or whatever it is. But if you take the magnitude, that z vector will go away. Whatever comes in the form of x and y, dx, dy. What is the limit of the x and y? That someone has to try. Try x equal to minus a to a and y equal to minus a to a. Okay, let's try and see. I have not tried, I would try, but this is something that is really research based, that can we calculate area of a circle through cross product of length of vector in x and y in r theta plane, then it will work. Is there any other way? Someone would say, well, this is very difficult. This is very difficult. D of dx, d by dx, d by dx of a square root of x square plus y square r unit vector plus tan inverse y by x theta unit vector, then this is very difficult. And then limit. Is there any simpler way? But this will give the solution. Anyone can try. We will try another way also. That is called 3D model. In x and y, it is possible. In Cartesian coordinate system, also the cross product of two vectors, one vector is in where the y is independent and one vector where x is independent, is possible. If I take 3D model, three-dimensional model, otherwise, is it possible in 2D model only? Yes, you have to go with the theta r plane and map x and y into theta r plane. Bring x and y as independent component in theta r plane as a function of r and theta as a function of x and y, and dp by dx, dp by dy, dx dy. Someone can try. Please do not mind supporting us. This is something I'm really sweating badly. Means this is something, it is not available in any of the book, but as per the concept, it should work. Please do not mind supporting us. +91 is the India country code, 94831 60610 is the telephone number. +91 is the India country code, 94831 60610 is the telephone number.